Thanks again to Killen and WoodSolutions for inviting us here today to speak. As Killen has already said, my name is Frank Davern. I'm the Regional Managing Director for HSP CAD here in Australia, and we're servicing the Australian, New Zealand markets. I'm based in Melbourne, but we have personnel based in Sydney and Perth as well. And here are some of my contact details. So a little bit about HSP CAD before we start. HSP CAD was founded in Ghent in Belgium in 1988. They were an engineering and design services office that serviced the timber market in Europe. From there, they developed their own solutions. In 1994, they released their first software solution called HSP CAD. Since then, we've been developing on top of the Autodesk products like AutoCAD and AutoCAD Architecture to bring design tools to the masses, basically. So from there, we are in over 11 countries with about 80 employees globally, focus on different tool sets from residential timber frame right through to commercial CLT, SIPs, post and beam, etc. tool sets. So today we're going to look at, as we said, HSP CAD, and it is a CAD. It's originally a CAD CAM solution, but it's much more than that today. So we're looking at some of the challenges today. What is BIM and offsite, the way we see it, and how offsite and onsite differ. What the solutions are and how they can assist businesses in optimizing what they can do and what they can offer to the market, and the different levels of prefabrication, what the future as well holds for this. So what does the future look like for HSP CAD, and what does it look like as well for the market? So we'll go straight in. So why offsite, for example? Choosing onsite over offsite construction, we see is like, can you imagine manufacturing your car in your garage instead of in the state-of-the-art factory today, like Toyota or Honda or those do, as an example? Can you imagine all those parts being delivered to your house for you to assemble? What are the issues around that? So the biggest issues around that. So what I was saying is, what would you expect if you were doing this? You'd expect delays, cost overruns, errors. And the question at the end of the day is, will it work? So we have the same kind of, can you imagine, this is what we do in the building industry today. We deliver all the materials to site, we get trades to build it. As an example, production builders, you could be a delay of 2 years now to get a house built on site, depending, especially based on these bigger production builders. So you can imagine the inefficiencies there today, and that's why we would have this building crisis that we have today, or this housing crisis. The other thing that probably differs from the car industry is, like, every building that we build is a unique prototype. It only gets built once. Even the production build residential homes, as an example, you might be buying a house from Metricon or one of those builders, but there's all these design changes, etc. So no one house is the same. So there can be issues around that. So the challenge is, how do we translate to your production method? Okay, so every manufacturer today to do an offsite construction may do some things differently, and globally we find that as well. So the materials we use to construct these products, a lot of the manufacturers as well have different machinery that they use. How do we translate what we do in our model to those machines? They have different levels of automation as well. You could have cultural differences as well. And the other thing is, what is your unique selling point for your business? What differentiates you from your competitors, as an example? And all of these points change in time as well. A good example here is, like, for example, the connection details for a panelized wall system. You may start off looking at what was done on site today for those types of connections, but then you see it's quite inefficient for manufacturing. So let's build upon those. Let's create what would be more efficient for your manufacturing processes, as an example. So what you need to do this, you need a powerful CAD CAM solution to do this, powerful and flexible CAD CAM solution to do this today. So what we're looking at here is just the pinnacle of offsite, as an example. So here's an example of Refuge de Gautier up in Mont Blanc. It's at a 4,000 meter elevation, as an example. You can see the complexity around this. You've only got a 2-month construction window. Each delivery had to be delivered by helicopter. So you can see a lot of planning had to go in to deliver this on site. So it was delivered and assembled on time, but upfront design, stakeholders like engineers, architects, the manufacturer all had to collaborate together to get this done in a timely manner and to get this delivered correctly. So this is a good example of how it worked. But we'll have a look at this as well. So complex project, very cost of transportation was quite high, and then you had a short building period. So what's BIM and offsite? And we're going to closely look at what BIM is. So build information modeling, it's just a digital foundation for the construction industry. I'll just move that slightly. Hopefully that is a bit better down there. So we've got four main headings here that we like to look at. So design and collaboration. Then we got planning, build, and operate. So planning, the estimating, the coordination of the modeling, etc. The build management, and then you get the build, which is the on-site, which is the project management, quality and safety, commissioning of the project at the end. And then you get operate, which is the life cycle of the building, basically, managing the building. So what's the build vision as we see it? We see there's going to be a lot more upfront design, and by streamlining that design upfront, you streamline the whole process. The planning can work off that 3D model, that initial information, and then on site build, you get this nice curve here, as you can see, where we've got 100% of the data at the end of the build, but you're progressively improving that. You can see there's maybe more iterations up front in the design and more stakeholders getting involved, but it streamlines the planning and the build phase. This is what we class as on-site build today. This is the vision. This is what we're getting in reality. So you can see it's well below that curve line that we just showed on the previous slide. So why is it like this? So at the design stage, stakeholders may not be working with and collaborating correctly. There's many different iterations. There's late decision points here. From a planning perspective, we could have already started building on site and we're still planning the next levels, as I said. So it's very inefficient as it is today on site. And it's very hard to get to the levels of 3D and 5D BIM without these types of inputs. So this is the kind of the graph that we'd see on-site construction today. There are plugins to this that would help improve this process. Like, for example, PlanGrid, you can see you got better planning tools and some improvements on the build side, but it still doesn't rectify the upfront issue with regards to the design, as an example, in those iterations at the early stages. So how do we look at this? And this, as I said, is basically the curvature for on-site building today. So where does offsite fit in here? So we look at HSB CAD as an example. We're looking at an industrialized offsite solution, much different from the traditional on-site construction. So at the design stage, we have the design tools and planning tools in place that allow us to create 100% reliable data for manufacturing and on-site assembly. So upfront, we're getting better designs. It means we can plan our manufacturing better and we plan our deliveries better. And then the on-site build is using the same 3D data that's being used for the design to show the implementation process, what additional items need to be used and installed on site with these entities, as an example. So you're building upon the accurate 3D model to get a more efficient process flow. So you can see our graph has dramatically changed from the on-site versus off-site. So you can see up front, we still have lots of improvement that can be made from the collaboration with stakeholders. But once the production design has been complete, that model is 100% reliable. It's got all the information needed for manufacturing and for assembly. So that's where we see HSB CAD fitting today in the design side, but there are other tool sets with regards to manufacturing and assembly, also streamlining the process. So what is the holy grail as we see of offsite today is, can you imagine your engineers and architects understanding the manufacturing capabilities of the suppliers and designing their buildings to suit those manufacturing processes? So yeah, spending more time up front doing concept designs to suit how these builds are going to go together, as an example, and collaborating more closely with the manufacturers. Then we've got another thing that's an issue today is we know the larger manufacturing companies and the larger builders, they're using ERP systems to manage their process. So they might have a CRM that contains a list of all their customers and all the jobs that are all the tenders that they're doing, as an example. And how does that integrate with the whole system from that perspective? So the CRM system does not talk to the design system, so it's all manual. Prove it, then it manually
Oh,
comes.
Frank.
Are you back, or am I gone?
No, we're all good. Sorry, Frank.
You're okay. Okay. So we're saying then once the project has been approved, the CAD modeling can start again. As I said, it's very manual. Everything here is like a silo. So there's manual uploads, manual downloads, areas where human intervention can affect the productivity of this whole process. So for example, everything is disconnected. But when we use systems like HSP CAD system, linking to ERP and CRM systems, we got bi-directional information coming through. So it's very flexible. So for example, you can do your initial concept designs in either Revit or AutoCAD. You can do your work sharing then with engineers and architects working off the same modeling, as an example. Our concept designs may be taken to a higher level to suit the manufacturing processes. The bi-directional information into ERP systems say designs have been complete. Now they're ready for contracts to be sent and estimates to be provided. Approval is given, then the design office can go straight back into doing their designing and finishing off their modeling for manufacturing. That modeling, as I said, can be driven from the ERP. So when the project is finished, it goes up to the ERP system, a sales order is created, and all the information, for example, from inventory, etc., when it's sent to production, that information can be consumed from the inventory in the ERP system, etc. Or new products can be created and added to inventory using these bidirectional. So we're getting more in the lines of 3D BIM and the bidirectional information. And with the planning information, we could go to 5D BIM, for example, with the project information that can be shared. So this is where we see the tools fitting today, and this is where most of the larger companies will get the benefit out of this workflow. So what are the tools and how do they work today? So from design to manufacturing assembly, we look at doing the concept design. So as I said, because we're built on top of the Autodesk platforms, you can do your design within Revit. You can also do your production and production design within Revit or within AutoCAD. AutoCAD is our traditional software solution. It's been around a lot longer, but we've been developing upon Revit for the last number of years as well. So you go from concept design to what you want on site. And we got 3 stages we cover here: design, manufacturing, and assembly. So in the design stage, this is where we look at the CAD CAM information. As you can see in here in this image, you've got two wall systems joined together, but you've got an abundance of CAD CAM information in here. For example, you've got milling and saw lines around the perimeter of all the sheeting. You've got electrical points that need to be drilled or milled out of sheeting products. You got lifting points that need to be drilled out of timber products. So all this all this CAM information is applied within the model, and that means that information then can flow straight through your manufacturing. So yeah, we do the detailing and tooling solution within the design of Revit or AutoCAD. And then that full 100% model then goes to the manufacturing. So the right data appears at the right place at the right time. So you can plan your production. You would have clients at every station within the manufacturing process. They would only see what they need to see at any given time. So they can manufacture wall components, roof components, floor components, modules within walls, roof or floor. You could have electrical stations where they're putting in conduit, etc. So yes, you can plan out your whole manufacturing and create the models exactly how they require, straight from the 100% data model that you have from design. And then that model can be shared with the cloud, so you can see how the items are going to be implemented on site or installed on site. You can see your truck deliveries from your manufacturing, as an example, what's being delivered on any given day. So instead of just looking at the CAD CAM design side at the very front end, we're looking at all aspects of manufacturing and all aspects of on-site assembly. So, and with the manufacturing side of things, everyone has different levels of automation, different levels of factory. So they might have a saw from one supplier, manufacturing line from another supplier. So you need a manufacturing system that's open, that's able to that allows you to work with what machines you have, as an example, and you're not don't have to solely go to one supplier to supply all, as an example. So here's just an example of historically the AutoCAD version of HSP CAD. See, as you can see, in this model, we received just a simple architectural model from the architect done in AutoCAD architecture. We can assign HSP CAD information already to that 3D model, mapping wall thicknesses and their location to say these walls are clad walls, these walls are internal plasterboard walls, etc. Then when we generate the modeling of the frames, you can see it generates the framework, it generates all the sheeting, etc. Your shop drawings are automated from that process. So once you create an AutoCAD model, you get your AutoCAD shop drawings for manufacturing. We also add tools. For example, we talked about CAM information. So here we're adding an electrical point. That electrical point is taking notches out of your bottom plates. In this example, it's putting no nail areas in, it's putting drills in your sheeting, and it's putting possibly even milling in your sheet zones if required to mill rather than drill. You're putting in your lifting points as an example. So putting in drills in your top and bottom top plates to suit those lifting devices. So all that CAM information needs to be applied to the model in order to drive your manufacturing. And most of those CAM tools are applied to the full model based on a set of rules. So you apply them once, basically, instead of applying them on an individual basis. Now, once that model is 100% complete, we're just going to look at a customer here from Scotland called CCG. They utilize HSPCAD for design, manufacturing, and on-site assembly. So in here, they do their 3D model within AutoCAD architecture, as an example. They'll store their project to HSP Make, where you can see a list of all your projects that are to be manufactured. The production manager gets a 3D view of the exact model that was created in the design. He has a schematic of his factory, so he knows all the routing through the factory, as an example. So we know what stations anyone is working on any given time, and we send them the correct material based on that routing. So you can see it's how important it is to have that information correct at the design stage to streamline your manufacturing. Here's an example of a paperless client at one of the stations to be able to view your wall panel. We send the CNC information around the nailing, milling, etc. So the software is basically driving your manufacturing. And the clients are just streamlining the process, minimizing the amount of time that they take to go back to the design office and ask questions about how this is meant to be assembled. They have a full 3D view. They can explode the view and look at each aspect of the panel. So we're getting close to the end of this one. So this is a high-level automation manufacturing. They take it to the next level. They put in their windows, battens, and then they get to the level where they're actually going to be putting in some brick. So I think this was done for the Commonwealth Games in 2015 or 2016 as an example. And they got their truckloads designed and then sent to site. And from there, the designs can be done in our cloud software. As an example, we can see each panel, where it's to be installed. There's issue management in here as well, and documentation. So you can say if it's delivered, if there's been an accident on site and you need to get manufactured again. So this is the kind of level that you could go to from there. So the designer will get that information back to him. There's also the ability within that software, for example, we want to be able to plan the on-site activities. So we want to be able to plan our deliveries. So from our 3D model, we can generate our truckloads. From each truckload, we know what components are on each truck. We know the weight of each package within the truck, for example. We know what's being sent to site. So the guys on site can get the information and be able to do the on-site installation. From this, like we said, there's different levels of prefabrication. So we've got customers that are doing tool sets, for example, like residential homes here, open wall frames. We've got customers doing closed wall panels, closed roof and closed floor panels. Customers doing SIPs, CLT, etc. So these are just some examples. We've kept some of the big ones that may not be operating still today. For example, Integra does a lot of nice things in North America. Katir was huge as well, but HSB CAD was with them from the beginning. But you got modular companies like Backlog that use us today as well. Kingspan Century in the UK, Space 4, CCG. With regards to CLT, the customers that we would have had in Europe, we reckon about 70% of all CLT uh, uh, developments come through one of our suppliers in Europe. 70% of CLT produced is through either Stora Enso, KLH, Haslacker, Sudra as an example. So here in Australia now we have Next Timber from Timberlink. They'll also be producing CLT and GLT products using HSP CAD. And some high level sophistication. So like the Cebu airport there, Ruber Holsner. Yeah, so lots of custom type development as well. So what does the future of offsite look like? So for example, we've got some customers that had investigated augmented reality. So looking at a floor system here with the plumbing and electrical in place so they can visualize it in the wall using HoloLens. So that's probably a bit old at this stage, and people are moving on from that. But as you can see, the technology is improving. Yeah, and I'll go to the next one from a HSB CAD perspective. We have been developing our solutions within the Rivet platform, so design for manufacturing. So we see more architects and engineers using our tools to create systems that best suit how they're manufactured. So not just putting in a wall to architecturally look right, but also that can be manufactured. So you got custom detailing within the Rivet environment called framing styles. It allows you to generate your wall and floor systems to that framing, and it'll allow you to send it to manufacturing. So the framing is automated. Do custom detailing in there as well. So we just have a look at a floor system in here where it's applying the framing information. You can see it's automatically generated. It's parametric to the model as well. So with work sharing, our manufacturers can bring in these models and manufacture from them. We've got an example as well as of some families in here that when you change the family size, it automatically will update the tooling in there as well. And this is quite a nice one with MEP. As we know, we get an MEP drawing in. We've got our framework in there already. We can utilize the HSP tools to apply the tooling to those frames automatically based on the MEP that's within the drawing. So you can create your production drawings automatically from here. But from a Rivet perspective, most of our customers are going straight from the 3D model to the manufacturing environment. Shop drawings, spending lots of time doing shop drawings is a thing of the past. They send up their 3D model straight to the manufacturing, and they get their viewers in the factory to manufacture. And you can send the same level of CNC data that you do in AutoCAD, you can do through Rivet today, as an example. So we just nearly finished there. This is Integra in North America. You can see they did semi-closed wall systems, a lot of framing, a lot of viewers you can see there, but yeah, the correct information going to each assembly point, and a bit of a repeat of how it flows right through then to HSP share. And the last thing I wanted to bring up is we've also been heavily investigating AI over the years. So we're utilizing it in the HSP Rivet product, doing some prototyping in there with regards to like steel, etc. So we're just looking at the moment as well as an example of an AI experiment where we did. So we did an analysis of a beam with a number of tenons and cuts in there as an example, and it feeds you the information in there. So you can imagine from a quality perspective, if you're doing some validations on your modeling, you could use this type of AI technology to identify parameters and features and changes as an example. So that's just the direction we're going in. We're definitely looking more at what we can do there. But thank you very much for listening. This is the HSP CAD team globally. If you have any questions or anything, please feel free to reach out and contact me. Cheers.
Good day from my side. My name is Crispin, and I'm from CAD. First, I would acknowledge the traditional owner of this country, which we meet today to have this webinar. I guess we dotted all over the place. So yeah, acknowledgement to the traditional owner, past, present, and future. All right, so CAD/CAM BIM software for timber construction. Thanks to WoodSolutions and Kylan to give me this opportunity. So the content of my presentation, a bit about history and the future, how to manage and integrate the CAD/CAM into projects, how to get a lot out of the software and have a smooth process, and last but not least, the BIM best practices and common pitfalls. So the history, I just did a bit of research. On the bottom, there's gonna be mainly CAD and machine related stuff. On top, the CAD or CADWorks history. So apparently Randek was one of the first ones starting doing NC machinery for housing up in the Nordic countries. Then CAD/CAM and the ideas about it got played around with early on in the 1950s, so that is around for a long time. CAD and CAM, computer-aided design and manufacturing, I guess everyone knows that. Then BIM, the ideas about BIM got started playing around with in the 1970s, building information modeling. Then around 1980, a few other well-known machine manufacturers got onto the market. That's as well the time when CADWorks started to be first developed at a school in Switzerland, and it was meant to be a CAD software for the watch industry. CADWorks then moved on to another school in Switzerland where they started using it for construction and timber construction especially. We started up the first companies and then providing CADWorks as a software through these companies in Switzerland, with the first branch then in Germany. On the CAM side of things, I would like to highlight the PTL format, which is like a common format to transfer design data onto the machine. It was developed as a master project at CEMA, one of the other CAD softwares, but then CADWorks and CEMA had like two different languages of PTL, which they followed on. CADWorks LexoCAD got introduced in the mid 2000, is a BIM and project management software. The BTL started to be a cooperation between CADWorks, CEMA, and LignoCAM. LignoCAM is a CAM software. BTLX format got introduced. We introduced CADWorks BIM Team, which is a cloud-based solution for model viewing, overlaying a 5C file, and BCF communication. And then last but not least, we started up a company as CADWorks Australasia 2022. I have been on the ground since 2018 looking after clients, and we had clients in Australia since early 2000. So what's today? You can see CADWorks is spread all over the world. CADWorks is a modular software with the core or basis as a 3D model, so it's a standalone software. It's not based on any of the other well-known CAD softwares. We have like 200 CAD workers looking after a big number of clients worldwide. Then to the future, virtual reality and augmented reality is one thing. So you can like walk through your building as a client to have a look what you're getting, or it can be used in the factory to look at a part and to see your processes on it. Then robotics, so that can be on site or in the factory, robots doing recurring work. Paperless factory. And then AI, which is maybe a bit more in the future, but definitely gets looked at. And we're looking at solutions on how to use that to do recurring modeling work and so on. And on the bottom, we have the BIM. I jump back in the past again. BIM level 0, we had like drawings or lines on paper. In 2000, we already were up to the third dimension with level 1. 2010, we had level 2, time and cost added. And in 2020, we were full integrated and collaboration with a cloud-based model, and as well and added a 6th dimension. And what's going to be in future, they are not 100% commonly agreed on, but there's going to be a dimension of sustainability, health and safety, lean construction, and this one here is the digital twin offsite construction, having a 3D model which replicates exactly what is going to be on site. But the interesting thing is, like the construction industry, we probably, or a lot of us are still like stuck back in 2010. So CAD work, in investing in the future, we will as well help our clients to get closer to where the standards are at the moment, or what's available at the moment, to get and close that gap. This is like a traditional workflow of construction, how to build a building. So from concept to closeout, CAD work and supply solutions for all of it. Here in Australia and New Zealand, we're probably mainly in the design and pre-construction phase with finalizing models, overlaying MEPs, making sure that there are no clashes, and then exporting data to the factory. Is that workshop drawings for manual processing, or CNC data to export machine files for your big and expensive machinery out in the factory. How to get the most out of software and have a smooth process. So I always like to look at CAD and CAD work especially as kind of a new toolbox instead of the traditional carpentry toolbox. So you have the box around it, which is your base, where everything is put onto top of, with all the different tools which you have inside. And to be able to get most of the software, you kind of need to know what your tools can do. But then as well, quite important is that the people using these tools need to understand what they try to achieve. So it can be a bit of a computer game if you're not knowing what you're doing, and if you're not knowing what you want to achieve. So with tolerances, making sure that things actually go together, which you model in the 3D model, and so on. And then a smooth process. I choose here a picture of a team. I think what I mean here is to have like setting up workflows internally from like when the data comes in to the factory and on site, how you want to deal with that, but then as well setting up workflows with your project partners, different stakeholders, on what you expect from them, what they can expect from you. Review these processes and implement them back into your workflow. So that's an example here. Is if you have like a machine out in the factory and it's doing certain things, that the guy feeds that back. If a certain process maybe takes a long time to process, feeds that back into the office, and they maybe can implement that and improve how they assign certain processes in the software to improve that. Now to the last point of my presentation, BIM, and to first just catch up on some of the terms and what it is. So we had 2D, 3D, and now we are at the I from BIM, building information modeling. So we're adding information to the model. An interesting thing, Annette von Hagel said, we have more knowledge about our coffee machine than about our buildings. So if something breaks, like you drop the water tank, filling up water on the coffee machine, you can go on the internet, order a new water tank, and you get that sent and can fit that into a machine without any problems. I think it would be a fair bit of a different story, say if a rafter breaks on your roof out of whatever reason, it's going to be hard to just go onto a catalog and order a new rafter for your house. So why are we doing it? Maximize efficiency, reduce cost, improve estimates. Because we have all the data in this 3D, in this BIM model, we can calculate way more leaner. We therefore as well get a better insight into our projects. It helps with the communication and collaboration. All these points reduce the risk, and in the end, we have a better result for us as well for the end client. And hopefully we can reduce stuff like this happening on site. This, by the way, is a firewall. So someone thought it's a good idea to put a conduit, which probably got forgotten about it at the design stage. Put that in with a couple nice cutouts out of the wall, and yeah, that's gonna cost some money to fix that issue. To the BIM method, I just would like to quickly go over that to get you a bit of an insight. I'm not sure how familiar you are with all the BIM stuff and what's involved with it. So in the middle here, we have all the different stakeholders on the project. That can be engineers, architect, prefabber, the BIM manager, and they generate ERs, exchange requirements. So they put on the table what they need from the building, from the BIM model. So that can be a line, a level of information needed, which on the other hand is the LOD in here, an example of a kiwi, the geometry, LOG, and LOI, the information which is attached with taste, color, and so on. As well, something to be mindful of, what we put in the exchange requirements. This washing machine on the left-hand side is in size 4 times bigger than the one on the right. So I would say a timber prefabber never needs a washing machine in his BIM model that detailed. Maybe like that, but probably even not. Then out of the exchange requirements, we generate the IDM or IDS, which is the information delivery manual that describes processes, make sure that the software on the receiving end can understand the data. You specified the attributes which you require, you specified what unit and what dimensions you want in there. Then this leads to the MVD. So if we look at this cube here, we have the whole IFC BIM model, and the MVD is just a portion which each stakeholder needs. So that's kind of as you would go into Coles and Woolies, and they have just all the stuff in one pile. But now these days they do a model view definition and everything is nicely and sorted and you just get what you want. And depending on what store you go into, you only have the sport shoes, maybe you have only the computers and electronics and so on. Model view definition is always as well related to the IFC version. I'm sure you have heard about IFC 2x3 and IFC 4. And then all that defines what's in the IFC file. And this is purpose driven by the ERs, and that's the medium which transfers the data. Out of that, a thing which always gets talked about is the open BIM. So we have little BIM to big BIM, small collaboration, a lot of collaboration, and closed BIM to open BIM. Closed BIM is if you have only one software suite within one company. Open BIM is if you can use the software which is the best in its trade. And what we are aiming for, I guess, is the big open BIM. So we have a common model. Everyone can work on that and grab whatever they need from this model. If it's that linear of a process, I'm not 100% sure, but that's where we're aiming for, and that's as well what's available with level 3 of the BIM. Now to the BIM pitfalls and challenges. I see a lot of the times BIM execution plans are not existent. So if that's not existent, you don't really know what you have to share, what you need to be in the model. It costs something. It can be sometimes quite pricey, especially if you start up new with it. If you start the BIM process too early, that can cause issues because you don't have the understanding on what's required in the BIM model. Using inappropriate hardware. BIM collects a lot of data. A lot of data requires powerful computers and as well storage space. So that has to be thought about when you're taking part at the BIM method. Using BIM systems with non-BIM systems. So if you have a stakeholder which wants to do stuff in the traditional way with paper and pens, that's going to be an issue how to implement that into BIM. If the building information which you receive is incomplete or inaccurate, it's going to start people assuming, and that's what we don't want. As well, the staff needs to be preferred if we want to take part at BIM. They need to understand what's required to do these processes and understand all these different terms. Quality. So you have to run quality checks and validation of your IFC files which you're sharing, and as well the model data you're sharing. Over modeling can be an issue as well, adding too much detail into your drawings which is not required at a certain station. Culture, I think, is a big issue, especially in the construction industry, which is quite of top-down, which, BIM relies on collaboration and communication, which kind of speaks against that. Revision and change management, how do you deal with all that, especially if we look at the traditional ways of like architects and engineer approving drawings with a stamp on it and a tick on it. How do you get all that information back into the BIM model? Often it's not happening these days, so we have to work on ways. There are already solutions available to do that all online and feed it back into the BIM model. And then a couple points which are more related to the prefabber. So the prefabber is often involved late in the process. That means as well he doesn't have anything to say with the IRs and what he needs in the BIM model. And then as well, there is still a lack of awareness or knowledge of prefabrication of the conflicting trades. So the MEPs still think they can just drill holes and cut things out of prefabricated parts which come on site, which is not that easy, often involves cost and delays the process. And lastly, on this BIM pitfalls and challenges, I think a lot of people think IFC, I supply an IFC and I take part of BIM. That's not quite the case. It's a bit more involved, as you saw in the previous slides. Then to the best practices, as little as possible, as much as necessary. Just because you have everything in the BIM model, you probably don't need to share all that. I often see like IFC files received by timber prefabbers which have like people sitting on the furniture, leaves on the trees. That's definitely not required for timber prefab. Avoid duplicates and collisions to minimize assumptions further down the track. Check your data. So a viewer, an IFC viewer, can be used to check content, information which is included, so IFC types and property sets and the hierarchy, but it's not necessarily liable to check geometry. Then use IFC validation tools. There are free tools around which work great. The IFC toolbox, I'm not sure if you're aware of that one. That's a Windows app or an app which has different tools in it. One is an IFC validation tool, or the FZK viewer, which is an IFC viewer with validation options to check the IFC files of its correctness, which is I think from a German university. And then check for defective parts, collision and duplicates. So if you bring in an IFC file into CAD work, we have like checks for defective parts. It highlights if they need to be fixed or not, collisions, and as well duplicates. And last but not least, collaboration. I think it's the most important thing, that you talk to each other and think about what data do I need, when, and from when, whom do I need that data from. Regarding model coordination, use consistent naming of your BIM model and all the submodels. This one here, the local position and orientation, is a fairly big one and causes a lot of issues that the models don't line up properly. One thing to notice, place your model as close to the local nil point as possible and have your model not extending all over the modeling space, because that's just going to cause issues further down the track when you share it. Assign the building and stories properly. That makes sure the hierarchy is nice in the IFC files and that all parts are assigned properly in the hierarchy. And then use the IFC types. So if we share this there without IFC type, the receiving software just receives a volume, and it's kind of up to the user to define what it is and what attribute it is. If you assign it the IFC type IFC stair, there's already a whole heap of attributes which come to it with it, the function, and it's as well placed correctly in the hierarchy, and we know what it's doing. So use IFC types. I often see models which have no IFC types assigned. That's definitely going to cause issues further down the track. Conclusion, that's as well my end of the presentation. Yeah, work together, collaborate, integrate, and then CAD and CAM are tools which have to be used appropriately, but they can be as well used and be open to different users. BIM is a process which has like certain specification and they need to be regarded. And the last thing I would say, crap in, crap out. So you can't expect that if you put something in which is not finalized, that comes out on the other end as a golden project. And that can be what you get from the engineer or the architect all the way to the end, but it can be as well as little of you exporting a beam and want that finished process of the machine, that you make sure that there's all the processes assigned to it, because yeah, we're not quite there yet that we can turn stuff into gold without putting effort to it. Thank you. And if you have any questions, feel free to get in touch.
Thank you, Crispin. That was awesome. And thank you, Frank, for your presentation. Those are both really excellent. It was great to see your parallel perspectives on this issue, and we got a lot of discussion in the chat, which is really good. So we have a few moments, so I think we'll dive into some questions. First one is from John Davern. It is, can you talk about the level of integration of structural engineering software like ETABS into BIM vision versus reality?
Sorry, what's that?
So can you talk about the level of integration of structural engineering software like ETABS into BIM softwares? Would perhaps Frank would like to take off on this for us first?
Yeah, well, I know with our design softwares, we do have integrations with structural engineering softwares like Doable, as an example. So yeah, we're able to export out our model and do their engineering analysis on that, or export out some line and point information for them to do structural analysis on our designs. Yeah, it's probably coming more with regards to the work sharing and working within the one model as an example. So as I said, we've piggybacked off the Rivet Autodesk platform, and there's a number of tools there already, like Robot, for example, that you can do your engineering analysis within there. So we're looking at items that fit within there, but for stakeholders that don't fit in there, like Crispin has just said, the IFC file format, being able to export an IFC file with all the relevant data for them to do their structural analysis and to be able to try and feed that back in, to be able to do a comparison to what's in the design is critical. So yeah, that's probably the route people will be going to. But yeah, we're kind of piggybacking off the Autodesk side of things. So anything that's within that environment that speeds up that communication and collaboration, that's the kind of tools we'll be looking at.
Yeah, so it's not perfectly overlaying at this point in time, but it's getting there.
Yeah.
Cool. Any thoughts on that, Crispin?
Yeah, it's pretty much the same here. I guess an IFC file is not really what you share with a standardized IFC file is not what you share with the structural software. It's more like nodes, lines, maybe a SAT file, the geometry, but at least you can like share that and have a common starting ground.
A great question here. Given your professional experience, how do you foresee AI and machine learning influencing CAD, CAM, and BIM? As you already touched on that intelligent query, Frank, in the HSB CAD space, and I imagine that there's both room for improvement, but also room for confusion if enthusiastically imperfect AI was let loose in these softwares.
Yes.
What are your strategies to sort of use these to the best advantage?
Look, the way we're looking at them currently is what can we do with them today? As an example, where can we fundamentally add something like that to improve our processes and streamline our design? So, like for example, we're looking at like lean management, being able to look at your design and see what timbers you can take out, as an example, or what light gauge steel items you can take out, or look at a bit of learning about what you do common in a design that you end up doing multiple times and see, yeah, can AI pick that up and automatically regenerate design based on those requirements. So there are possibilities. I see it really good as from a quality perspective, doing a QC check on your modeling, making sure that what it knows about your manufacturing is that what you design is capable, can be manufactured. So yeah, for a simple thing like a router tool around the edge of a CLT panel, that yes, that tool does exist. It is in the manufacturing environment, this can be actually manufactured. So those types of validations and checks, yeah, and possibly even changing the model to suit those items. So yeah,
It has the capacity to dramatically reduce the collaboration effort and things that are often missed during collaboration too.
yes.
Have you got any thoughts on that, Crispin?
Yeah, we used AI to model our image for the Christmas card. I don't know if I would have wanted to send that straight to the machine. So there is, I think, definitely I don't think we're going to be able to use that soon to make the whole process. But as Frank said, I think for certain small portion in the whole workflow with reoccurring work like checks, validation, applying details and updating details in different locations for stuff like that, it can be definitely used, and we're already looking at that to implement stuff like that.
Yeah, we could look at stuff like writing scripts quickly as well. So like, for example, within our software, we've got scripts that we do to add tools to drawings, etc., to speed up the designs. We could look at AI writing code for customers so that they don't have to be a programmer to write those things. So AI could be used in that way as well, like it's used today. But yeah, we're probably a few years away from something like that.
Interesting. We're going a little bit over time, but I think this is a great question, so I want to put it forward. This comes from Sergio. The level of BIM in the design stage has been low, and this is something that we're all pushing to increase. The question is basically, how do we make sure that the benefits are reaped by the right person to where the risk, where the costs are at the beginning of the project? How do you see a successful project politically structured, I suppose?
That's a tricky one.
This is a big question to end on.
It is because because there is a cost to this, and we see architects engineers collaborating, which are probably smaller stakeholders in the overall size of these types of projects, and manufacturers as well trying to work into that as well. So yeah, it's who absorbs that cost. But I think we have to look at it from a manufacturer's perspective. As an example, if we are designing, collaborating, and creating a model that can be manufactured, that doesn't have to go through millions of iterations in the design process, there is a cost to every call we have to make back to an engineer, to an architect, to a client, to make changes to these models. And it's, if we can streamline that, there is a cost saving in the manufacturing and the design from that perspective. So yeah, I think it has to be absorbed by everyone to a certain extent, and I think it will just be a common thing that we're going to be doing going forward anyway, that architects, engineers, and manufacturers will get used to working in this type of way.
Well, certainly the teams that do it best will thrive together as a group. Have you got anything to add from your perspective, Crispin?
Yeah, I think as well there is probably a new kind of stakeholder which needs to be introduced in the whole process, with like a BIM manager or a BIM specialist on the project, because at the moment, yeah, it gets either done by the architects or by, a lot of the time I think it gets done by the timber prefabber, because he's the guy who needs the most accurate data.
Hmm.
And I don't think that they are the people which have 100% all of the knowledge to take on the role as BIM manager. And then, yeah, these costs have to be shared. So everyone probably has to give up a bit of his pie and put it towards the person doing the BIM management.
Awesome. Well, we're just about out of time. Thank you both so much for being here. I personally got a lot out of that presentation, and I can tell from the engagement that the audience did too. So thank you both for being here, and we'll see you around the traps.
Cheers. Thanks again, guys.
Thank you.
Thanks, Killen.
My pleasure. Before we sign off, I'd like to talk about the Timber Design Awards, which are now open for this year. So if you know any projects that are completed in the last year that are impressive and great examples of timber in a range of different categories, from resi to commercial fit outs, standalone, even like landscaping, everything from the opera house to a bus stop. It was made from timber and it's remarkable. We'd love to see it. So make sure that you get your entries in. And lastly, the next installment in the webinar series will be next month on the 7th of May, and it will be on the Sydney Opera House renewal, which was, of course, the overall winner of the awards last year. Fantastic project. Goes into a lot of great detail on the digital fabrication that was used to create these beautiful hardwood waves that you're seeing there. So look forward to that, and we'll see you in the next webinar. So thank you very much for joining, and have a great week. Ciao, ciao.